Hello and welcome to Sports Performance Science. This is part 4 in our series around designing plantar pressure measurement protocols using insoles, stance pads, and walkway sensors. So for our webinar today, the key takeaways are first, to understand the different purposes and goals of testing with insoles, stance pads, and walkway sensors. You're going to learn about how to correctly perform and standardize your testing and training using plantar pressure measurement and gait analysis devices. And finally, experience some practical guidelines and measurement protocols for different sports applications. For our agenda, after our introduction, we're going to talk a little bit about XSENSOR's intelligent dynamic sensing platform. And then Antonio, who's joining me, will get into designing a measurement protocol, talk about the technology, mats, and insoles, some of the needs, goals, and purposes of those, and then into the standardization of those measurements, and finally, creating some benchmarks for performance and rehabilitation. I'm Bruce Malkinson, Chief Operating Officer at XSENSOR Technology Corporation. Been with the company for about 15 years and involved in all of our different applications for pressure imaging technology. And with me today, I have sports scientist Antonio Robustelli. Antonio, tell us a little bit about yourself.
Hi, I'm Antonio Robustelli. I am a sports performance consultant from Italy, working all over the world since more than 15 years. My area of expertise includes injury prevention, application of technology in sports, strength training, programming, recovery techniques, and in the last years, I've been focusing on the user application of plantar pressure mapping technology in professional sport.
Great, thanks, Antonio. A little bit of background about XSENSOR. So for about the last 25 years, we've been building pressure imaging systems with outstanding accuracy, image quality for nurses, therapists, vehicle interior designers, tire designers, safety engineers, mattress retailers, and manufacturers all over the world. Some of the key areas that our products are used in is in the application of continuous skin monitoring, specifically targeted at the prevention of pressure injuries in hospital beds, surgical tables, and wheelchairs. Second, product design and safety testing, which includes many automotive applications in the design and ergonomics of vehicles, as well as testing for safety and impact. And finally, in sleep improvement in the design of mattresses and design of systems to help consumers find the right mattress in a retail setting. The evaluation of plantar pressure and gait can provide key insights into optimizing athletic performance, and without it, those gains may never be realized. Many of the existing plantar pressure and gait measurement devices and systems are just not suitable for real-world testing in clinical sports performance or research applications. XSENSOR's intelligent dynamic sensing platform reveals accurate gait and motion data to help biomechanics and clinical professionals optimize human performance. So Antonio, I'll hand it over to you to tell us a little bit about designing a measurement protocol.
Hi, let's start with the first part of this fourth webinar of the XSENSOR Sports Performance Science series. Let's talk a little bit about the definition of a protocol. What is a protocol? Let's say that a protocol is a set of rules established for treating and or assessing, testing an individual, a person, an athlete, a player. In the field of science, a protocol is considered to be a set of predefined procedures for designing and implementing a specific experiment. Protocols are normally designed whenever there is a need to ensure standardization of procedures and reliability of results. But we need to make a difference between a protocol design in a research setting, in a research, for research and scientific purposes, and the protocol design to be used in a practical setting, in an applied setting, like a sports performance goal. In a research setting, the first step is to identify a problem. So the first step is what we call in research problem identification. Then, after having identified the problem, the second step is to develop a hypothesis. So the hypothesis development is the second step. And then the third step is creating and working on the design of the research regarding the data collection, the statistical analysis, and the data interpretation and analysis. In a sports, in a clinical and practical setting, like in sports performance, after having identified the problem or what we want to measure, the second step is to identify main goals and needs of testing. And then after having identified the problem and needs, the last step is to look at the every specific and environmental variables, like the type of sports, if it is an individual or a team sports, if it's a strength or power-oriented sports or endurance sports, the key performance indicator of a given sport, the time availability, and so on. And we will see this in detail later in the webinar. As we have talked about the difference between protocol design in research and in a practical setting, it is fundamental to get a step back to talk a little bit about what is research. As research is more than just a gathering of facts or a gathering of information or a practical pursuit of data collection. Research requires the use of a systematic process to develop and test a specific question in order to arrive at a new conclusion. We know that research design, like the protocol design that we're going to discuss in detail during this webinar, the design of a research is fundamental because it's basically it is the backbone of good research. A good research design is the one which determines data collection, statistical analysis, and drives and guides data interpretation from the outset. And also, it is important to point out that when talking about protocol design and research design, the planning of the protocols is going to lead the process and is representing the most important aspect. This is a very interesting slide summarizing and visualizing the cycle of a research process, starting with the research question, which is the fundamental problem that has been identified. After the research question, the second step in the cycle is and after having justified the question and the research, the second step is the data collection, so collecting the data. After having collecting the data and having checked the quality of the testing process and the collection process, the third step is the analysis of the data. After having analyzed the data, it is time to describe the findings and explain the findings. And last step is the reflection on the findings that have been obtained from the data analysis. Just for your understanding of the protocol design in a practical and in a clinical setting, I like to show you what is one of the most interesting scheme in sports science from a study from Bishop, which is going to define the various stages of the research design protocols. He basically identified three main stages: description, experimentation, and implementation. And each of these three stages has different substages, like defining the problem, development of the hypothesis, the identification of the predictors of performance, then the experimentation stage, where you need to test and experimental testing of predictors, the determinants of key performance predictors, and then the last stage, which is the implementation studies in a real sporting setting. Now, let's start looking at the protocol design in a clinical and in a real setting, in a real sport conditions. There are different questions you need to answer when trying to develop your own protocol for testing your players and for testing your athletes. The first question is, what is your goal? And you have two main answers when it comes to plantar pressure mapping application. Is your goal testing performance, or is your goal monitoring rehabilitation and return to play for an injured athlete? The second question is, what do you want to measure? Do you want to measure a general pattern? For general pattern, we mean a movement pattern which is common to any type of activity. Or do you want to measure a specific patterns? And for specific pattern, we mean a pattern, a skill, which is specific to a given sport. Third question is, what is your sport? And for this question, you have two types of answer or sub-question. Looking at performance model of your sport, so what is the main energy system contributors to this sport, and what are the main qualities required for the sport, and also if it is an individual sport or a team sports, and looking at the time availability. Different sports, different professional sports have different time availability. Football teams in first division has less time available for testing players respect than an individual team where you have more time to work individually with each athlete you are working with. This is an interesting slides where you can see what is, this is just for an example. And this is an example of a decision tree in a research statistical analysis. It is mainly outside of the scope of this webinar, but it is just to give you an idea of the process that we need to follow also in a practical setting. In a research statistical analysis, you're starting with asking, what am I trying to measure? And you have two basic answers. You are going to measure a relationships within groups or a difference between groups. Based on your answer on your needs or research needs, if it's a relationship within groups, the question is, what type of data do I have? If I have parametric data or non-parametric data. Based on that, you can choose a different type of statistical model and statistical analysis, whether it's a Pearson correlation, a Spearman rank order correlation, and so on. Same apply for measuring differences between groups. What type of data do I have, if it's parametric or non-parametric? In this case, you have other sub-question to answer if you are testing same participants or different groups and so on. Based on various needs, you have different type of statistical model and analysis to choose in order to conduct your statistical analysis of your research. Based on a decision tree in a research statistical analysis, I'm going to show you now a decision tree in designing a measurement protocol in sport. The first question, the starting question is, what is my goal here? Is it testing performance or monitoring rehabilitation? If you need to test performance of an athlete, of a player, you need to ask what I want to measure, a general or a specific pattern. If you're going to measure a general pattern, which is, as I already told you before, a pattern which is common to any type of sports, and for general pattern, I mean a basic movement pattern like a regular normal walking gait. If it's a general pattern, then you are going to measure a baseline in order to, and we already talked about baseline in our previous episodes of the series, a baseline measurement in order to look at any deviation from the baseline during the season, during the follow-up measurements. And this is mainly the main goal of the general measurement of the baseline measurement, is to analyze overall biomechanical biomechanical condition of an athlete and of a player. If what I want to measure is a specific pattern, then you need to ask, what is my sport? And looking at difference between a strength or power oriented sports and an endurance oriented sport. After having identified the type of sport, the last steps are related to the difference between a team sports or an individual sports, and the type of key performance indicators required for the sports. A strength-oriented sports or a strength power-oriented sports, let's say like sprinting in track and field, or also football or basketball, where speed, acceleration, and also change of direction are very important, is going to affect the protocol design respect than an endurance event like marathon or 10K, where you are not interested in looking at acceleration in the propulsion phase, but you are mainly interested in understanding how the athlete is able to maintain biomechanical efficiency for a longer period of time. If the goal is monitoring rehabilitation, the question is, and this is very, very important, is the question to ask is, do I have baseline or pre-injury data? Having pre-injury data when dealing with injured athletes is fundamental, because you need that pre-injury data in order to track changes during the rehabilitation period. And if you have this data, you can use them to compare especially the pressure distribution and the path, the trace of the center of pressure during the data. If you don't have the baseline and the pre-injury data, the use of pressure mapping becomes more helpful as a active biofeedback tool, and just for not only for testing but for training, active training. And this is an aspect that we're going to show you in the next webinar of the series, which is mainly focused and dedicated to biofeedback tool, to pressure mapping as a biofeedback. Let's look at the various type of hardware that we have available for plantar pressure mapping technology. We have basically three types of hardware: the stance pad sensors, the Walkway sensor, and the H4 insole intelligent insoles. The stance pad sensor, as you can see from this slide, here you can see the hardware as well as a screen of the data output in the software. The stance pad sensor is used for what we call static analysis. What are the main characteristic of a stance pad? Is as you can see, it is a wireless device, and it is important in sports, especially in a clinical and practical setting. The wireless option is fundamental because you can move very quick the systems in a facility, and also in the field if you need testing on the field. There is no calibration required. There is an USB interface plug and play, and easily portable, and there is a cover for both barefoot or footwear during testing. The Walkway sensor, as you can see, is being used for dynamic analysis, and we will see the difference between the two. For dynamic analysis, so you basically need to walk or run when stepping on the mat. It's a flexible and can be rolled up for transports. You can set up it on any flat surface as a plug and play design as well. And the overall setup of the hardware and software is very fast because it's in under 10 minutes, and it has a high resolution mat with more than 7,000 sensors. The last hardware is the intelligent insole sensors, which are being used also for dynamic analysis. The main difference is that with the insoles, you are going to measure directly what is happening into the shoes when striking the ground. And it is completely wireless. If you have followed our previous webinars of the series, you already know that these insoles are only 1.8 millimeters of thickness, so it is undetectable to the wearer, to the user, and it is this is a fundamental feature to minimize any change in biomechanical patterns. Has a resolution of 230 sensors per foot, and weighs only 42 grams. let's look at the needs, goals, and purposes of mats and insoles. A lot of professionals interested in starting using plantar pressure technology in their daily practice with athletes and players asked me about the difference of the mats and insoles, and they asked me about how to use and when to use them based on the output. This is a general classification of the main use of the different hardwares. For the stance pad, the stance pad sensor is the system used for static analysis. What do we mean for static analysis? Static analysis is basically involves standing still on the mat and measuring the overall biomechanical stability and balance in a standing static position. It is being used for looking at the peak pressure, having a peak pressure image. We talked about peak pressure image in our previous webinars. It is being used for rehabilitation, for biofeedback training, and you will see this in our next webinars, and also for balance assessment. So it is very, very good, the stance pad sensor, to look at the biomechanical structure and efficiency in a static position. The Walkway sensor is being used for dynamic analysis. Most of the time, if you are looking for some compensation to occur in a static analysis, you should see a direct translation in dynamic. And the Walkway sensor is being used for mainly walking gait, for shoe fitting, for foot function, and for rehabilitation. The sensors are really more specific, still more specific, because they are still for dynamic analysis, and they are very, very useful for evaluation of speed and running, for sport-specific movement, for show fitting as well, and for return to play, because you can analyze players directly on the pitch and on the ground to understand when they are ready to training and to handle more load again, or to go to competition again. Now it's time to introduce the concept of standardization. Standardization of measurements is a fundamental step when talking about testing and measurement in general. But what is standardization and why do we need it? Let's define standardization in this context. Standardization is a procedure used in science to increase the validity and reliability of research. When it comes to clinical and practical application in a real sports, in a real life sports setting, standardization is a method used to gather data for specific testing and evaluation purposes. And why we need to use it? We need standardization to ensure reliability of measure and to allow comparisons, and also to facilitate confidence among various staff members using the technology for testing players. I mentioned the term validity and reliability. Let's have a quick look at the meaning of these terms. Reliability is how repeatable a performance test is, and it is essential to compare an athlete over time. Validity is the ability of a given test to measure what it's supposed to, and it's fundamental to compare among athletes. Let's look at a stance pad sensor. This is an example of a measurement standardization that we use in our practice with our athletes. As you can see on the picture, this is a regular position of an athlete on the stance pad when performing a static data acquisition. First, you should let the athlete or player step on the platform. In the picture, you're seeing an athlete without shoes, because we are interested in this case to analyze the overall function of the foot and the overall stability of the athlete without shoes. If you want to measure the influence of a specific shoes on biomechanical outputs and overall stability, you can test with the shoes as well. Our advice is to test both without and with shoes. It is important, if the test is barefoot, to let the athlete perform some foot mobility exercises before stepping on the mat, at least for 3 minutes. This is because when the athlete take off the shoes, what we want to see to minimize any type of interference from the shoes, as the athlete can show some tightness and still some tension on the foot because of constriction into the shoes. It is essential to perform some foot mobility exercises for at least 3 minutes. Then you can, before starting the acquisition, you need to be sure that the feet are aligned on the same horizontal axis and in a comfortable position. Then you can start the data acquisition. 5 seconds are enough to have all the information you need, but the range for a static analysis is from a minimum of 5 seconds to a maximum of 10. If you need to perform a balanced assessment, you should repeat the acquisition with the difference in feet position based on the contemporary evidence from the scientific literature, with the feet 30 degrees wide open and the heels at 2 centimeter distance. With the Walkway sensor, we're performing a dynamic data acquisition. Like the static analysis, you can choose to test barefoot or with the shoes, and it depends on your needs. Our advice is to perform both tests to have more information available and to look at how and if the athlete is changing some pattern based on the type of shoes he is wearing. So let the athlete player, these are some quick tips that you can use for trying to keep your measurement as reliable as possible. So let the athlete player step on the platform. Again, if the test is barefoot, let the athlete perform some foot mobility exercises for at least 3 minutes to have a free after taking off the shoes. Then it is important to, especially at the very beginning, when a player is still not accustomed to the device, it's important to let the athlete work on the mat without starting recording data, and let him walk for at least 8 footsteps in order to for them to get used to the contact with the mat. Then you can start recording data to capture at least we capture at least 12 total footsteps, so that you can when you're going to analyze the data, you can choose the best footsteps and footprint in order to make an analysis. With the Walkway sensor, you can test both a normal gait, walking gait, as well as a running pattern. Another important aspect when testing athlete, especially in a team context, is how to create benchmarks for performance and rehabilitation purposes. Here, I want to introduce briefly the topic of presenting and visualizing the data, which is very, very important. In this graph, you can see three main steps when using pressure mapping analysis and presenting and visualizing the data. Starting with data acquisition, whether it is with a Walkway sensor and intelligent insoles or a stance pad sensor. The data analysis, which is fundamental, and we have 5 main type of analysis that we perform with pressure mapping analysis that we have explained in our previous webinars. And this type of data analysis are divided in peak pressure, image distribution, center of pressure, trajectory, the 3-box analysis, the cyclogram, and force time and pressure time curves. After having analyzed the data, there is the problem of context. And the problem for context, we mean all the type of environment in which we are performing the measurement and where we are implementing the technology. Planning is fundamental. Having a plan, the needs, so having a goal, and the time available. Time available is fundamental also because it understanding that the time availability allows the coach and the person who administered the test to decide to create an automatization into the context in order to having the player and the athlete well educated when performing the test on the technology. So to summarize, for presenting and visualizing the data, it is important to have in mind these 3 steps: the context, the data acquisition, and the data analysis. How to visualize the data and how to present the data is a fundamental problem, especially in a team sports, where you need to use the data in order to explain all the findings to various members of the staff, medical staff, the head coach, and so on. But how to present the data? Are we sure that classic graph, like the radar graph that you can see in this picture, are really the best solution to present the data? Or maybe we need a different approach in this case when talking about plantar pressure mapping technology? I like this paper from J. Hertel. A picture tells 1,000 words, but most results graphs do not. We need to use the data to drive intervention, but how we can present this data? It is better. What is better, a graph or a picture? There has been, I like this quote from this paper, there has been recent criticism in the scientific community of a heavy reliance on simple bar graphs and line graphs to illustrate results, because they often fail to clearly represent the measures and changes to interventions of individual participants. This article aims to suggest alternatives to bar and line graphs, including those that emphasize the illustration of individual subject measures and dataset distribution, magnitude of group differences, the relationships between multiple variables, and unique ways of displaying time series data. Why I showed you this paper? Because when dealing with plantar pressure mapping, the presentation of data through image is more powerful in order to drive intervention respect than ordinary bar line graphs or radar graphs. So this is why in this context we need a radical change in how we approach to data visualization. Let's get a step back to the benchmarks for performance and for rehab. This is another, if you remember the decision tree that we have seen before, this is another tree when we need to decide how to benchmarks for performance and rehab. For performance, we need basically plantar pressure mapping for two main reasons: injury risk screening and profiling for biomechanical efficiency. And for these purposes, we can use all the three types of hardwares. We can use the insoles and the stance pad for injury screening, and the insoles and walkway for biomechanical efficiency profiling. For rehabilitation, we can use pressure mapping for mainly for two goals: rehab, live time biofeedback, and return to play decisions. The stance pad is very, very helpful for rehab and live biofeedback, and the insoles and the walkway are helpful for tracking the return to play of an athlete. But when talking about benchmarks, normally we need to deal with some what we call normative reference values. There are still no reference values for athletic population. Using reference and normal reference values related to general population with athletes is a waste of time. So when talking about benchmarking for athletes, it is much more important to look at deviation from a baseline. So making comparison within athletes and not among athletes because of highly individual biomechanical output of each athlete. With foot pressure mapping, we have a more granular data set and analysis, because it is not, this is a very important concept to understand. It is not about how much force you can produce or how high you can jump or how fast you can run. With plantar pressure measurement, it's about the ability to properly transfer force and control center of pressure through optimal neuromuscular balance. So when talking about plantar pressure profiling, comparing among athletes is not desirable. This is why having a baseline measurements at the beginning of a season is fundamental in order to understand and screen for any change during the season, and to decide how to change training, therapy, and so on accordingly to the change that you are recognizing with follow-up testing during the season. In conclusion of this fourth episode of the Sports Performance Science series, what we did is we explored in this webinar the different use cases for when to use insoles, stance pad, and walkway sensors depending on your unique purposes and goals for testing, whether you need static or dynamic analysis. We also explained you how to correctly perform and standardize your testing and training using a stance pad sensor for static data acquisition and a walkway sensor for dynamic data acquisition. Lastly, we provided the concept and difference between protocol design in research and in an applied practical setting for use in different sports applications. I will wait for you in the next webinar of this series about how to use plantar pressure measurement technologies for biofeedback for training and rehabilitation. Thank you very much.
Thanks so much, Antonio. We appreciate all of your fantastic insights and your time and commitment to delivering this webinar for our users. You can get in touch with Antonio at OmniAthlete.com, and you can reach out to XSENSOR as well at XSENSOR.com. Thank you.